this one here. So you supposed to download this nearest school midterm exam file. Okay, 25 points for this midterm exam. Actually, this is just single exam, so we don't have other exams, so this is the only exam. So let's look at this data set. There's data set here. So here, this is FL, school ID, and G10, urban, FL, SES. So this is variable name, and this is observation names, right? So if you scroll down, how many observations exist here? How many of them? 829, right? So go back to here. Okay, let's start to do number one question. So here, this question, unique observation. So unique means that there's no overlaps. Everybody is a different person. So the unit is called a unit of analysis, and the school ID. So this is the individual school. So even though you see the unit name here, ID, school ID, it's possible for you to think, okay, this is just random stuff, SCH, rather than the school. But at that time, you can think about how this can be school, or this can be individual student, or individual state, So let's look at this one. So for example, urban is the urban. So maybe school is located in a rural area, or suburban, or urban area. So depending on one area, if the data collector assign a specific number to each area, for example, number 1 is urban, number 2 is suburban, number 3 is urban, rural, something like that. So it looks like that, even though it has like point that. This is just the categorical number to each area. So individual person still can be assigned to individual, area, right? So this one single variable does not tell, okay, this ID is about school or students, but you keep going this way. So here, SES, SES. So school can be located in rich area or poor area, right? Or individual person is the same situation. So keep going. Teacher influence. By the way, this NERS data has a codebook in Sakai somewhere, data folder in files directory. Okay, if you cannot know what the location is, just email me, or you simply Google it. NERS data in the Google, then you can see the codebook about NERS data. So teacher influence, teacher happiness. So individual school has this kind of index, right? Because the teachers belong to one school, right? And teacher happiness level, teacher community or commitment, and other kind of things, principal leadership. So based upon this comprehensive investigation, you conclude, this ID is about school. Does it make sense? So you can keep doing that. Also, this is school nurse data. We have school student data too. Anyway, I almost said the answer, but anyway, so let's move on. The school ID here is almost, I hit the answer. Number 2, so I scroll down the data set until the end, the bottom. So you choose one answer, right? And which variable is not unordered categorical variable. So ordered categorical variable is like a 5-point Likert scale. Strongly disagree, neutral, agree, disagree, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right? This is ordered categorical variable. If you have like a math score from 0 to 100, this is continuous variable. But here, unordered categorical variable is like just dummy variables. For example, gender, male or female. it doesn't have a like hierarchical order. Female is superior to man. That doesn't make sense. So this is, what is it? You have to look at, open the data, and then go to variable view. You have to search this one. Label and value, so you have to find out the property of the variable. Okay, so let's go back. Read this hint, okay? Female, male. Create a histogram, this variable, so locus 2. So this part, this question has two parts. First, create a histogram. Second part, copy and paste. And then third part, brief describe the shape of the distribution. So let's go to the question. 2. So locus 2, FL locus 2. This is right, 29th, locus 2. So analyze, instead of analyze, graphs, legacy dialog. Did you see histogram here? Yes, here it is. Histogram, and the 29th around here, right? Okay, locus 2 here, and then put display normal and hit the button. Okay. You have to wait. Running graph. So it takes time. My computer is so slow. Okay. So once it is done, it's gonna be disappeared, okay? Takes a lot of time. Yeah, processing. Right. So now you just click this one, copy, and paste. Answer. So once you copy this graph for this assignment, then at least you can have like a half a point or 0.3. If it is 1 point, you can have like 0.3 point because this includes 3 parts, right? And the copy paste, okay, you did it, right? And then now what? Brief describe all of the shape. Description of the shape of the distribution. So distribution, this looks familiar, right? So this is a look. Hint, when it comes to description, you have to summarize characteristics in terms of 3 elements. So these elements are covered under normal distribution. So this is normal curve, right? So you can write it down. If this is a unimodal or bimodal, 2 peaks or 1 peak. If this is positive skewed, negative skewed, this is quite symmetry, right? No skewed symmetry, right? It's bell shape or something else. So even though it's symmetric, it's possible for the graph not to be normal distribution. For example, uniform distribution. So here, you see it's not uniform distribution. It's a bell shape, right? So you can write bell shape. Okay. And then number 5, G10 control 1. So now bar graph. Now you're gonna draw another one. So as you do the same way that I did here, graph, legacy dialog, bar graph, you find out bar graph, and then simple define, just follow the default. And then it takes time. So here, whatever variable was indicated in the question, you moved here. For example, like, let's say do this one here. And then now what? Okay. So you have 3 bars, right? So in this case, urbanicity variable is a categorical variable. So that's why it shows bar graph. If it is a continuous variable, it doesn't look like this pretty way. So now, what did you do? So, this is not the question, the variable the question is asking about. You have to choose the right variable here. Control variable, okay? I just chose a random variable like urbanicity. So choose percent case for the bar represent. So once you have this, click the right mouse and then intent content. So here, percent property. How could you choose bar option, field? So you have to see, oh, how can I do that? Bar option, depth, variable. Oh, there is no. Okay. Here, percent. You show data level. Element. So you have to do everything. Option, element, edit. What was the question? Bar option. Yeah, I forgot it. I don't know. What was that? Do it again. Choose percent case for the bar represent. What is bar represent? Bar represent. How can I find that? Bar represent. Label. Value? No. Bar represent. Show data. So here, right mouse, and then show data label. Show data label. Okay, so show data label. So this is a frequency. We want to know what? Percentage, right? So here, percentage, not count. Okay, apply, close. So you have to have the percentage to answer the question, right? Here, copy and paste, like this, okay? So you choose the right variable, okay? I just chose random variable. Q5, Y's bar graph is an appropriate display. Why? As I said, this is a categorical variable. So each category is shown, right? So bar graph is good for categorical variable and continuous variable is good for histogram. Public, Catholic. So maybe this question is about school type. So once you see the percentage, you need to write down public school percentage. I mean, which one is bigger than the other? You have to choose. And then number 8 question is what? Exact percentage here, right? Yeah, public school. And the box and whisker plot, you just follow this YouTube. You can get the exact answer, okay? Report median. So when you want to see median mode and locus, this is also what? Go to analyze, locus 2. Okay. Analyze descriptive statistics, frequency. Okay. Locus 2, locus was here, right? So locus 2 and statistics, median mode, like that. Continue. Okay, so you can play with the chart, bar graph, pie. Okay. If you choose more options, then it takes more time, but let me see. Where is the descriptive statistics? Is still going on. This is it. Locus is not good for bar. Oh. Yes. I'm not sure if I chose the right variable, locus 2. Did I choose locus 2? Anyway, once you copy and paste this output, it shows median, mean, mode. Oh, you need to choose one more variable, teacher influence. So follow the right instruction, okay? Yeah, hint, the procedure in the SPSS. And now what you're gonna do is 1, 2, 3, 4, 5 variables. Using these 5 variables, you want to have one SPSS output. So mean, variance, standard deviation, range. This is where, let me show that to you. So analyze descriptive statistics. So let's do just one variable, okay? Teacher happiness only. When you have time, you have to do everything to answer the right answer, okay? Go to teacher happiness. Descriptive statistics, analyze descriptive statistics and descriptive statistics. Where is the teacher happiness? Here it is. There it is. So before option, let's go before you choose options. How many options do we need to choose? Mean, variance, standard deviation, and range. 4. Okay. Standard deviation and range. Variance, standard deviation, and range. So here, mean, standard deviation, you don't want to do this. Variance, range. Continue. Okay. So now you have at least one variable, descriptive statistics, copy, and come here. If you choose all of the variables, you might have one big table to show everything. Okay. Okay, now I don't have time, so we don't have time just to show how to do it, okay? So now, correlation table. Correlation table, let's go. So teacher, principal, leadership, let's just do two correlations, okay? Like one correlation between two variables, okay? Teacher happiness and principal leadership. Oops. Okay. Go to analyze. Okay, correlate, bivariate. What was that? Teacher happiness? Is that teacher happiness? And principal leadership here. And then, okay. So now copy. If you chose all of the variables, you might have a big correlation table. But now I just chose only 2 variables. So it is so small. Anyway, copy this table. And here, okay. And then teacher happiness and principal leadership, you fill in this yellow cells. So principal leadership, teacher happiness, the correlation between 2 variables is 0.363. 0.363. Okay. And what did it say? Significant. It's significant at alpha 0.05, and here alpha is 0.01. So here 0.01, 2 stars, and this is 1 star, 0.05. So what do? You have to have star here too, okay, as it is, okay. Okay, follow this procedure. Okay, now regression analysis. So you will have 4 predictors and 1 dependent variable, and how we can conduct regression analysis using these variables. This is how we do our research project too. So that's why this midterm exam is very important to process your research paper project, okay? what we're gonna do is, once the SPSS generate 3 outputs, we have to copy and paste these 3 outputs. If you miss one table, then you wouldn't get full credit. Okay, so let's follow this procedure. Say, here, okay, analyze. Oh, I forgot it. So teacher happiness is outcome variable. And let's include principal leadership and teacher influence, okay? Because it's confusing. It takes time, so principal leadership and teacher influence. Principal leadership and teacher influence. Descriptive statistics? No. Regression? Yes, regression. Linear. And teacher happiness is outcome variable, right? So here. And now what? Something like principal leadership and what was it? Teacher influence. Okay, so you have to add more, okay, as the question is requesting. So here, once you add right number of variable, why this is not moving? Oh yeah, yes, this is it. Statistics, estimate, click, model fit, and descriptive. This is enough. This is enough. Continue. Take it out. Continue. Okay. Just do it one time. I just wanted to make sure. Plot. Okay, this is about assumptions. This is about assumptions. Okay. You didn't, some students haven't watched the assumption video yet, right? So if I show this one, you might be lost. But since this is a guide for exam, I'm gonna do this. So what is this? This plot is for assumption checking, in particular with homogeneity assumption. So this first one, Z is normalized, standardized. Pre means predicted. So this first one should be X. Okay, this is predicted residual. You remember that? Residual is the same as errors. Okay, and then this is regular. I mean, Z standardized residual, just residual. So Y. Okay, and histogram normal plot. Okay, histogram normal plot. Continue, because this shows some weird looking plots, which is the index that we can diagnose whether or not this is violating the assumptions, especially homogeneity assumption. Please keep in mind, watch the YouTube video first, okay? Because that is the basic lecture video. But if you do not watch that, then this midterm exam guide wouldn't be very understandable for you, okay? Continue. And save. So here, actually, you don't need to do anything. Well, DF beta, this kind of things, some functions for detecting outliers, but this class, we just skipped it. Okay, just skip it. Options, just leave it alone as default, and you don't need to go to style bootstrap. This is kind of standard error simulation stuff, so you don't need to do it. And then okay. So what we were doing now, this is a regression analysis. And then when you conduct the regression analysis, this shows some kind of option here. What? Regression assumption checking. I told you, if assumption is not satisfied, your analysis wouldn't be trustworthy. That's why it has this kind of side options. Okay. Anyway, let's look at it. So right now, descriptive statistics, because you chose descriptive statistics as one of the options. And correlation, yes, correlation too. This is a correlation among all of the variables in the model, regardless of independent variable, dependent variable. Okay. So move on. From here, regression analysis, the three outputs that the question is requesting, okay? So here, model summary, you have to copy, okay? And the question, open it. So one, model summary. So model summary answer. Oh, this is title shows that you don't need to even type this one. Complicated. And then number two is what? ANOVA. So go back to output. ANOVA. Copy. Okay, ANOVA. Oh, this numbering is bugging me. I think I copied the table is the wrong spot. Model summary first. Yeah, model summary and here ANOVA. And what is third? Coefficient table. Go to coefficient. Copy. Number three. Whenever you copy and paste something, please do it in order. Otherwise, I mean, if you copy this coefficient table in some other place, I do not give full credit because you do not answer what I wanted to know in the right spot. Sometimes students have so many outputs and they just copy all of them and then put them together in the one weird location. That's not something that I want, okay? You have to answer the question accurately to the right venue. Here, model summary, ANOVA, and coefficient. Okay, so first one, model summary is about R square. And since this is a multiple regression, we want to report adjusted R square. And second one is ANOVA table. So why do we do this? So even though we have R square, so this is a high explanatory power, right, about the model. So proportion of explanation using your model for the variation of Y. Okay, that's the definition of R square, right? So even though this is pretty high, so how do you know this is pretty high? Even though this is pretty high, do you trust this high index? Without this, you do not know that if it is really statistically meaningful. Okay, so how do you know that? I mean, how do you know this is even high? Do you remember that? Cohen's rules of thumb. So R, the small, medium, high correlation, the threshold, 0.1, 0.3, 0.5. Do you still remember that? And then you square it, the number. Okay, then the high correlation was 0.3 or 0.5, 0.5, right? So 0.5, square it at 0.25. So this number is pretty similar to 0.25. And this number is pretty close to 0.25, right? So it's regarded as a high R square, kind of like a between medium and high. But this 0.208 is close to high R square, right? According to Cohen's rules of thumb. Do you remember that? Model test video has that. Cohen's rules of thumb. Remember that. That's important. So you can say, I mean, this doesn't ask interpretation yet. Anyway, this table R square, just R square shows pretty high R square. Okay, so this model is good, but that's not all. how do we say that R square more perfectly? You have to provide F-test and p-value. F-test and the p-value, right? So this is about your model test. That's the first step. So first report R square, and second report whether or not that R square is trustworthy. That is shown in the ANOVA table, which are F-test and p-value. So this sig column shows p-value. So this p is smaller than 0.05 alpha level. Alpha means criterion, threshold. So in social sciences, we choose 0.05 as alpha conventionally. So anyway, this is smaller than 0.05. So that means your model is statistically significant. Yay! And then once your whole model is statistically significant, then the next step is you want to find out which slope, which x variable is statistically significant. Maybe all of them are statistically significant, or maybe one or some are statistically significant. In this case, I just chose 2 independent variables. So we want to find out which one. Oh, yay! This is T statistics. T statistics p-value is both of them are statistically significant. So that means your model is good, and also all of the independent variables in your model are statistically significant. The end. That is the interpretation of how to interpret the regression analysis, period. Okay, so here, write down the estimated regression model. This is the estimated regression model, right? So y hat equals what? Minus 6.048. Y hat equals minus 6.048 plus 0.129 x of principal leadership x variable plus 0.533 x of teacher influence. Do you know what I'm saying? Y hat minus 6.048 plus 0.129 principal leader plus 0.533 teacher influence. This is the estimated model. But the thing is always be sure to identify all parameters and components in the model. You know what I'm saying? So I was trying to save time. So here, all components and parameter, you have to explain this one. So B0, this is B0, Y hat is the Y value. The Y value, what is Y? Teacher happiness. The teacher happiness value when all X is 0, you plug 0 here, 0, then you have this number for Y value. Okay, this is the definition of Y-intercept. So here Y means teacher happiness. Oh, sorry for this wrong spelling. Anyway, you fix them, okay? You fix them. And you have to define what is X1, what is X2. So here you have to define that like this. And B1, slope 1 parameter. Slope 1 parameter is this. Well, how do you define this? Here, when principal leadership changes 1 unit, whatever value here changes in Y, controlling for other X variable. Okay, ceteris paribus. Remember that? Ceteris paribus. If you don't include this one, it's wrong answer. It's like if you have a simple regression, no problem. But if you have a multiple regression, then you have to include this one for sure. Okay? So same way, this number is y value when x of teacher influence changes 1 unit. Okay? Yeah. And then status variables. Okay? All other x variable controlled as a constant. Okay. What is it? If you add like here, I subscript, if you say you have 820 something numbers, people, whatever, then what? You individual people? No individual people. This is school data, individual school. Okay? So this is individual school from number 1 school to 827 or 29. What is this? This is, I think, component of X. I don't know. Something is missing. Yeah. X variables are here. I already put down here. X. Okay, Y variable this. So this is the right answer. But this is not the complete answer, right? Because you have to add more variable. More variable. Okay? Can you do that? Yeah, you can do it. Alright, so hint, if you cannot understand why this is estimated regression line, read this hint, okay? And based on, do you want me to upload this study guide? Yeah, I will post it, okay? In the assignment section. But that doesn't mean this is the right answer. It shows just how to do it. Okay. Number 15, model summary, well, something is wrong. Okay, so you don't need to read this one because I already showed this one. So this is a wrong question. Sorry. So here, so how you determine how much variance in the DB, dependent variable, is explained by independent variable. Sounds familiar, right? This is the definition of what? Definition of R square. But don't forget about the multiple regression. This multiple regression require the use of just R square because of multiple independent variables. Okay, this is overestimated, so we have to choose this one. If we have to choose for this model, because this is predictors a lot. Okay, so R is a proportion of variable. No, R is correlation. So variance, you remember that it's not square rooted. So this is not R. They are not the same scale. Okay. R square is proportion of variance. Y dependent variable that is explained by independent variable. Oh, sounds good. And 24.4%. So this shows probability scale. So probability maximum is 1. So if you convert that to percentage score, the total score is 100%, right? So 0.248 supposed to be 24.8%. So here, 24%. Sounds good, but R square. So somebody say, adjusted R square? What is it? So leave it alone, because when you are not sure, just leave it alone and then move on. See, adjusted R square is not useful, because R square is more preferred. No, this is what? Multiple regression. So this is obviously wrong. What is the question? Most appropriate. Most means that there's some blurry area, but you need to choose the most appropriate interpretation. So most appropriate one. So B, C, standard error of estimate. This is SEE. What is the standard error of estimate? Sampling distribution of your estimate, right? Okay. Is a proportion? No, this is not proportion of variance. SEE is square rooted. Root xi minus x bar square. This is kind of portion of MSE, mean square error. That is the same scale as variance, but this is already square root something. So this is obviously wrong. This is about the formula, so you might be confused a little bit. Anyway, so last week we touched based on this concepts using the mathematical formula. Yeah, so go to the video if you are confused about this one, or just email me if you are not sure about the formula. Okay. Anyway, the most appropriate one is this. So if it is more perfect, then you might say like, adjusted R square. Because this is what? Multiple regression. But some people keep missing this word because it's kind of obvious to them. Yeah. So just to choose the most appropriate one. Number 16. So coefficient table. This is a t-test table. Okay. So this is a t-test table and this is p-value. All right. So this is constant means y-intercept. You don't interpret it. And this is principal leadership and teacher influence. These two variables are statistically significant. But urbanicity, this is not statistically significant at alpha level 0.05. This is larger than 0.05. And school classification reported maybe this is public school, Catholic school, those kind of thing. And it's also statistically significant. All right. And teacher contentment is dependent variable. Anyway, here, inappropriate. Okay. So principal leadership is 1 unit higher. Teacher happiness level is expected 1.33. So teacher commandment is what? Is this the happiness? Yeah. So when X is 1 unit higher, Y is 1.33 higher, for people with the same level of all other, same level means make a constant. So controlling for. It sounds good to me. Okay. And when teacher influence 1 point higher, teacher happiness level is 0.395 higher for people with the different level. So all other factors should be same. And then now you are comparing this. But if these conditions are different level, how could you even believe this one? So it doesn't sound right. In one standard school, so if you see one standard blah, blah, what do you do? Go to this one. This is standardized coefficient beta weight. So the unit, the scale here, standard deviation. So here, A and B has used the unit for this X variable and this X variable. But here, when you interpret this beta weight, your unit is all SDs. So then you can compare all of the magnitudes among the variables. You don't compare the magnitudes among the different variables using unstandardized coefficient because each has a different unit. But once you go this column, you can compare, 0.249 is higher than 0.227. Does this make sense? But here, you don't say 0.395 is larger than 0.133. You don't say that because they are different units. Okay? So now you go back to one standardized school classification. Higher teacher happiness is 0.213 higher with the same level of all other X variables. Yes, sounds good. And then when one standardized urbanicity higher, teacher happiness is 0.015 SD higher. Where is 0.015 standard deviation higher with the same level? 0.015, where is it? Ah, this is it. This is urbanicity. Yeah, it's right. Right? Urbanicity, yeah. Okay. So this implies the urban schools have a lower slope on the Y outcome than rural school. You do not know this fact based on this unless you go to dataset, urbanicity. Where is urbanicity? Where is urbanicity? Is this urbanicity region? No. Oh, here, urbanicity. So number one, what the question is talking about is the comparison between urban and rural. So urban happen to be coded as 1. Rural is happen to code it as 3. So if rural is the same direction with the Y, it's a higher number. Remember, which one is a small number, which one is a higher number. And let's go to the interpretation. Here? No, not that. Here? Okay. Urbanicity. So this is a positive number. So the direction of X increase, the direction of Y go together. Positive means. So here, rural was coded a higher number, right? So rural implies urban is lower slope. Yes, urban is lower slope because urban was coded 1 and rural was coded 3. So small number has a small slope. High number like urban coded 3, it's higher slope. Are you confused? Okay. We will go through this in class. So if you are not sure about this, let's go back to this in the class meeting, okay? Anyway, this is the way how we interpret slope, the relationship between X and Y. Slope means the relationship between X and Y, okay? All right, so no problem. Yeah, here, hint. I show this one here because this question is not only depend on this table. If you do not know the labels, which one was coded with which number, you couldn't understand this. That's why I showed this hint here. Okay. But other people, even though it does not show this code here, people already know. Go to this variable view and then open it. Then you see, oh, which one is this? They have to understand it first. This is kind of like a miniature of your data analysis for your research project. This is how to do it, okay? All right. This is kind of simulation for the data analysis. Exam is not actually exam. This is a good one. All right. So let's go to the question. All right, here. So question 16, can you identify p-value for the slope each IV? Yeah, this is the interpretation, right? Interpretation of the hypothesis test. Did you listen to the video very well? Actually, this was covered in 628, but I repeat it again and again. maybe students are too busy, so they learn that in the 6 to 8 very well. But once the winter break or summer break, you spend time with other things, and then you forget many things, and then now you feel like, oh, this is very new to you. Yeah, we have to keep practicing the concepts again and again, so then we won't forget it. How do you decide reject or not reject? Okay, significance means p-value, yes. Null hypothesis is k is predictor, so beta equals 0. Yes, it's right. Urbanicity has no relationship. Let's go to the urbanicity has no relationship. So null hypothesis is urbanicity slope is 0. Beta urbanicity is 0. Now, your p-value is larger than 0.05, which means you fail to reject the null hypothesis. So here, go back to the null hypothesis. No relationship. Since you fail to reject the null hypothesis, yes, C is right. True. Teacher influence. No relationship. Go to the table. Teacher influence. It has relationship because you reject the null hypothesis because it is smaller than 0.05 alpha. So go back here. This is wrong. Number 18, draw scatter plot. Teacher influence, happiness. Actually, this question is supposed to be in the very beginning because this shows linearity assumption. But anyway, now what I'm going to do is here, whether or not you know how to detect the regression assumptions are violated. Using what? Different kinds of graphs, okay, or function. So here, let's go to data, teacher influence, and teacher happiness. Teacher influence, scatter plot. So plots, graphs are graphs. Scatter plot. Simple, always simple. And the teacher happiness was Y. Am I right? Let's go to the question. Teacher happiness is Y. Teacher influence is X. Teacher happiness. Where is the teacher happiness? Let's drag. Ooh, like that. Happy, 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 happy. And influence X. Okay. This. And open, edit, content, separate window. You're gonna add this one. Regression 9. Close. Okay. Not because of this line, but because this scatter plots has kind of weak or medium-sized slope, right? Now, copy. Go back to the homework. Here, draw. So the slope is this, 0.7. It's a pretty high slope, right? Yeah, so here, we have only one single x variable. 0.7 is very high. 0.7 is very high. What else? So, follow the hint, okay, to generate this plot. And then, can you conclude linearity? Yes. Yes. Satisfied, yeah. Do you see any kind of strange looking, like quadratic or cubic, or like strange one, right? No. So this is good, even though there is like outlier, little something, but still okay. And you can write it, why or why not. A linearity assumption is not satisfied. We cannot use a correlation index. Yes. This is a true statement. True statement. Why do you say that? Why do you say that? Correlation does not guarantee linearity. Okay? Correlation index does not guarantee linearity. So what we're going to do before we conduct the correlation table, we have to draw the scatter plot to see if the relationship is linear. Okay. We really have to read the PowerPoint titled Assumption many times, because that's about our data analysis quality. Yeah. And then assumption PPT satisfy any assumption. Okay. Symbol notation, words. So this is about residual assumption. 3 residual assumption. So if you didn't read assumption PowerPoint, really, please read that assumption. So let me just show that. This is notation. We can combine several assumptions to say residuals are independent and normally distributed with mean zero and common variance. So mean zero, and this is constant variance, errors variance. Okay, and 2 shorthand notation for this. This is notation. So what you're gonna do is this: copy. Then here. Oh, it's not copyable. You have to type it down. Symbol. Look. Okay. And then what you're gonna do? Words. Move here. Okay. This is the right answer. But the more important thing is, can you interpret it? So this tilde means distributed. IID means identically independent, distributed with n normal, mean zero, and standard. This is variance because of square, or standard deviation, sigma error, or you say variance. This whole thing is variance. Okay. Residual. This is error assumption. Okay. I also provide a cheat sheet. Okay. I provide 3 files for this assignment: midterm exam question, and cheat sheet, and NELS SPSS dataset. Okay. And now after this, I'm going to post this guide in that assignment folder too. Okay. Copy and paste the appropriate plots for error variance. Do you remember error variance? I told you homogeneity assumption. And satisfied in terms of normality histogram and homogeneity assumptions. Let's do it one by one. It requires 2 assumptions. Number 1 assumption, normality. Number 2 assumption, homogeneity. So this is also shown here. Normality. This is normality. And homogeneity means errors are evenly spread homogeneously. So that means this is constant. Constant number, regardless of the x values, constant. The size, error size is similar. Homogeneous, not heterogeneous. Okay. So here constant. If you have like some functions here, that means it's not homogeneous. But this is constant. Okay. One single number. Okay. The size, constant. So y variable, this is x-axis, y-axis. Your residual distribution is like a rectangle. Okay. Anyway, so how do you do that? We already did it. When we run the analysis, regression, we chose this one. This is it. So, even though here outlier, between +4, between -4, It's kind of spread. It doesn't look like that or like that. We regard this as like a rectangle. Of course, you can say, here more chunk, then here more sparse, and here like put together, very busy. You might say that. So your interpretations can be slightly different. And so your conclusion, whether or not you say, okay, this is not homogeneous or heterogeneous, something like that, can be different. But I see the way how you interpret it. That's why you have to put your words. Okay. Anyway, regardless of your interpretation, the plot is gonna be same, right? So I know you know the assumption checking. So here, homogeneous. Number 22 is just to use dependent variable, this, and copy and paste. That's it. No more action. And then after that, 23, now you interpret. So here, this is the homogeneity. And then homogeneity is done. Now what? Histogram, normality. You did the two. Here, two plots. Histogram, residual histogram, and normal PP plot. Here only histogram, you might say normal PP plot. What is PP? Probability. Okay, here it's almost overlapped on the one diagonal line. But normally I don't require that. As long as you provide this histogram, I give full credit for normality. Anyway, so these two for normality, and this residual plot, homogeneity. And now you interpret for 23. Can you conclude normality? You have to write it, blah, blah, blah. It looks like what is the normal assumption? Three elements, symmetric or not, skewed, and then bell shape or different shape. And what else? Unimodal or bimodal? You have to explain that. Okay. Number 24, homogeneity assumption satisfied your interpretation. As I said, on the x-axis, y-axis, looks like a spread evenly between -4 and +4 on the y-axis. Okay, that is the interpretation. Okay, if you think, oh, that doesn't look evenly spread, then you say, oh, it's violated homogeneity assumption based on my observation. This is wider and this is shrunken in the center. You can say that everybody has different sensitivity, but what I want you to do is provide the evidence. The evidence is already here, right? Okay. And then 24, STEM and, okay, here, follow this one, okay? Follow this one, so you can do it. Oh, yeah. So here, so histogram, okay, I gave you it like that. Okay, and save this way, and then post it on the right menu, assignment folder. Bye.